Buffers. A buffer is a solution that will resist pH change. There are many situations where you don't want the pH to change much. Like in your swimming pool, you don't want large fluctuations in pH. In your blood, you don't want pH changes. So the way this works is buffers have significant amounts of a weak acid and the conjugate base. So if you throw some base in there, the weak acid will neutralize it. If you throw acid in there, the conjugate base will neutralize the acid. So you've got some of both, and so it can handle what you throw at it. So your blood is a buffer. Your normal blood pH is very tightly regulated between 7.36 and 7.4. Very, very closely regulated. If it goes below 7.0 or above 7.8, you're dead. So let's look at an acetic acid sodium acetate buffer system. So we have the acid, acetic acid, present, and we also have the conjugate base, sodium acetate. So if sodium hydroxide is added to this, the acetic acid will neutralize it. If we add acid like HCl, the base, the acetate ion, will neutralize it. And so whatever you throw at it, it can neutralize it and maintain the same pH. So here's an illustration of that. So it's very important that this be a weak acid because you need the acid present and the conjugate base. And in a strong acid, it ionizes completely and all you have is the conjugate base. So this is a weak acid. So here we have intact acetic acid molecules, and we also have acetate ions because it does ionize partially. So if we add hydrogen ion to this solution, the hydrogen ion can react with the conjugate base, the acetate ion, and form acetic acid that neutralizes that hydrogen ion. If we add hydroxide ion to this solution, it can react with the weak acid, forming water and the conjugate base, and the hydroxide ion has been neutralized. And so the pH is affected very little, if at all. So what you need to be able to do is identify what is a buffer solution. So a buffer solution contains a weak acid and its conjugate base. So let's look at this system here, H2SO4 and H2SO3. Well, is this a strong acid or a weak acid? That's a strong acid. Is this a conjugate base of this one? No, this is also a weak acid. So here in this first example, we have a strong acid and a weak acid. What we need is a weak acid and its conjugate base. So this is not a buffer solution. Let's look at this weak acid, though, and ask ourselves, what would the conjugate base of that be? What do acids do? They donate hydrogen ions. They donate protons. They lose hydrogen ions. So when we put this in water, H2SO3, the water acts as the base. This is the acid. The base is the babysitter. So the base is going to take the hydrogen ion, becoming a conjugate acid. This will be the conjugate acid. And this will be our, I'll call it CB, the conjugate base. I ran out of space. When the acid loses a proton, it becomes hydrogen sulfite ion. Any questions about that? So if you had H2SO3 and HSO3, that would be a buffer system. This is the conjugate base of this weak acid. But this, here we have a strong acid and a weak acid. That's not going to help us at all. Let's look at this one. HF and NaF. So this is the acid. Is it strong or weak? So there were 6 strong acids, right? The halide ions, so there was, HCl, HBr, HI. HF, remember, is the little sister. Fluorine's the little sister. She's weak. She's not strong. So this is a weak acid. So here we've got a weak acid. So looking good so far. Is this the conjugate base of the weak acid? Well, let's think about it. It doesn't look like it, does it?
Oh, no, it is.
It is. Sodium fluoride aqueous. That's a soluble ionic compound. That's sodium ion and fluoride ion. Okay? When this weak acid loses a proton, when it ionizes, it's H plus, and this is the conjugate base. So the conjugate base is the acid after you take a hydrogen ion off. So this is a buffer solution because we have a weak acid and the conjugate base. The sodium here is a spectator ion. It could be potassium, could be ammonium, could be almost anything. So how about HCl and NaCl?
No. Strong acid.
Right. It looks very similar to this one, but because HCl is a strong acid, it's not a buffer system. It has to be a weak acid. This is a strong acid and its conjugate base. But when a strong acid is in water, there's no intact acid molecules, and so there's nothing to neutralize a base when you throw it in there. How about this one, sodium chloride and sodium hydroxide?
Yes.
So I have a bold yes. Which one is the weak acid? Is this an acid? No, it's not an acid. Here we have a base, but we don't have a weak acid. You gotta have a weak acid and its conjugate base. Okay, so this one also not. Any questions? Yeah.
I'm not understanding the strong acid HCl.
Okay. So, strong acids. HCl, HBr, HI. Perchloric acid, nitric acid, sulfuric acid. So the way you identify whether it's a strong acid or a weak acid, if it's on the list, it's a strong acid. If it's not on the list, it's a weak acid. Why that's important is because a strong acid, when you put it in water, will ionize completely. A weak acid, like HF, only ionizes partially. So if you look at an illustration, you're going to have a lot of HF molecules, and you're going to have some fluoride ions, and you're going to have some hydrogen ions, but you're going to have intact molecules as well. With the strong acid, there's no HCl molecules left. they all split up. So that's why the distinction is important. Did that answer your question? Any other questions? So when we have a weak acid and its conjugate base, they are both present in solution. So we have an acid there and we have a base. So hydrogen ions come in, they can react with this. Sodium hydroxide comes in, it can react with this. And so the pH can be maintained at a whatever it was. It won't change much. With HCl, all we've got is hydrogen ion and chloride ion. And the chloride ion is not going to do anything.